This is example 4 of using half-angle formulas to evaluate trig expressions. So here we're given that the sine of alpha is -4/5, and alpha is between 3 pi over 2 and 2 pi. So we have to figure out, okay, what's the sine of alpha over 2, what's the cosine of alpha over 2, and what's the tangent of alpha over 2. Okay. So we've done a lot of problems like this before, where we're given some information like this, and we have to determine what quadrant is alpha in, and we set up our reference triangle and things like that. So let's go ahead and do that down here in the corner. Well, before we can draw a reference triangle, like we just said, we have to know what quadrant is alpha in. So notice here, alpha is between 3 pi over 2 and 2 pi. So if we make a little chart real quick, so here's 0, then up here is going to be pi over 2, and then pi would be over here, and then if we go around here, that's 3 pi over 2, and then back around full circle is going to be 2 pi. Okay, so alpha is between 3 pi over 2 and 2 pi, so alpha is somewhere here in the fourth quadrant. Okay, so when we make our reference triangle picture, we're going to make sure that we put it in the fourth quadrant. Okay, so let's go ahead and do that. So down here, we'll set up our reference triangle in the fourth quadrant. X-axis, y-axis, quadrant 4, perpendicular. Okay, so here is our angle alpha. Okay, now we're told that sine of alpha is -4/5. So remember, sine is opposite over hypotenuse. So sine of alpha is -4/5, and that's opposite over hypotenuse. Okay. Zoom in a little bit on this. Now it's kind of weird to talk about opposites relative to this angle alpha here, but just remember that what we can do is talk about it relative to the reference angle here. So this angle right here is the reference angle for angle alpha. So we can talk about this opposite and adjacent and hypotenuse relative to the reference angle. So the opposite side is going to be this side here, so that's 4, and then the hypotenuse is 5. And again, we've done it what feels like hundreds of times in earlier videos, but let's call this -4. Why -4? Because, well, here sine of alpha is -4/5, and if we put the minus sign into here, then we don't have to worry about it later on, okay? Once we actually start evaluating these expressions here. But if we don't put it here, then what we do have to worry about is, okay, we're in this quadrant here, so we have to worry what's positive, what's negative. I don't know, we got to be careful about that. But if we just toss it into the picture right now, everything's fine. Okay? Why do we put it on the 4, not the 5? Well, because the hypotenuse should always be positive no matter how you're doing this. Hypotenuse is always positive. And it should be on the 4 because start at the origin, go in the positive x direction. So whatever value of x this is, we'll call it x for now, whatever value that is, it should be positive. And then from here we go down in the negative y direction. So start at the origin, always start at the origin, trace around the triangle here, positive x direction, negative y direction. So that's going to be a -4 for that reason. Okay. Now, what's that x going to be? Well, you might identify it's a 3, 4, 5 Pythagorean triple, but even if you don't, it's not too difficult to do the Pythagorean theorem. X squared plus -4 squared equals 5 squared. X squared plus 16 equals 25. Subtract 16 from both sides, x squared equals 9. Take the square root of both sides, so then x equals plus or minus 3. But like we already said, we take the positive square root because we go in the positive x direction here. Start at the origin, go in the positive x direction, so positive 3, negative y direction, -4. Okay, so now we have that. So now with that, we can get the cosine, the tangent, any other trig function we want. So let's see which one we actually need. Okay, so we'll zoom back out a little bit here. Okay, so we're doing some half-angle stuff here, right? So what we're actually going to need, if we go back to our formula sheet here, if you want to copy this formula sheet, check the video description. There's a link in there. You can use that link to get a copy of this. Sine of alpha over 2, cosine of alpha over 2, and tangent of alpha over 2. If we look here, these all involve cosine of alpha, okay? And the tangent also involves sine, which we're given. But we're going to need to know what the cosine is. So let's come back to our reference triangle and say, okay, I'm going to have to get the cosine, because I need that cosine of alpha to evaluate these guys here in part A and part B at least. Okay. So sine of alpha is -4/5, we were given that. The cosine of alpha is going to be what now? Cosine of alpha, let's come over here. Cosine of alpha equals the adjacent over the hypotenuse, and remember, adjacent relative to the reference angle. So the adjacent side is 3, hypotenuse is 5, cosine of alpha is 3/5. Okay? Okay, so that's what we have there. All right, now we're almost ready to get started. There's actually one other thing we have to determine. What is it? Well, let's talk about it when we get there. So let's go ahead and go here, back to part A, and then let's evaluate. So sine of alpha over 2 equals, if we go to our formula sheet here, we see that sine of alpha over 2 is plus or minus the square root of 1 minus cosine of alpha all divided by 2. Okay, and this is good because now we know what cosine of alpha is. We just found that out from our reference triangle picture down here. But now the problem is, which do we take? Do we take the positive or the negative? Well, notice on our formula sheet here it says the sine, SIGN sine, plus minus, is determined by the quadrant of alpha over 2. Okay, so what quadrant is alpha over 2 in? Well, it's not really, it doesn't jump out at us right away, right? What do we know? Well, we know this up here. We know that 3 pi over 2 is less than alpha is less than 2 pi. So what if we divide everything by 2 in there? So divide everything by 2. So 3 pi over 2, divide that by 2, is less than alpha divided by 2 is less than 2 pi divided by 2. Okay, so let's zoom in on that. 3 pi over 2 divided by 2, that's 3 pi over 4. Alpha over 2 is alpha over 2. 2 pi over 2 is pi. So so basically you just take this inequality that we were given, divide everything by 2, and then you're going to get an inequality for alpha over 2. So that's the idea, that's how we do this here, that's the idea there. So alpha over 2 is sandwiched in between 3 pi over 4 and pi. So where's that? Well, if we make a little picture real quick. So here's 0, pi over 2, pi, 3 pi over 2, and then here's 2 pi back over here. Okay, so alpha over 2 is less than pi, but it's also greater than 3 pi over 4. Where's 3 pi over 4? Well, 3 pi over 4 is here. Here's 3 pi over 4. So alpha over 2 is between 3 pi over 4 and pi. So wherever alpha over 2 is, it's somewhere here in the second quadrant. Okay, we don't know exactly where it is. We don't really care exactly where it is. All we know is that it's sandwiched in between 3 pi over 4 and pi, which means the relevant point there is that alpha over 2 is inside of the second quadrant. Okay, so what this means is that alpha over 2 is in quadrant 2. So sine, that's what I meant to write. So sine of alpha over 2 is positive, and cosine of alpha over 2 is negative. Okay. So remember, if you're in quadrant 2, your sine, SIN sine, is positive, and your cosine is negative. Okay, and tangent is also negative. We don't have to worry about that one so much, but why not just write it and be thorough. Okay, so again, just to recap real quick, start with this inequality we were given, divide everything by 2, and we end up with 3 pi over 4 is less than alpha over 2 is less than pi. So that tells us that alpha over 2 is somewhere here in the second quadrant. Okay. So since alpha over 2 is in the second quadrant, sine of alpha over 2 is positive, cosine of alpha over 2 is negative, tangent of alpha over 2 is negative. So now if we zoom back out, that tells us that for part A, we're going to take the positive root. Okay, because the sine of alpha over 2 is greater than 0, we just found out. So we're just going to take the positive root, so we just leave that as it is. Okay, so then this equals the square root of 1 minus cosine of alpha, we know already is 3/5. We found that out from our reference triangle earlier. Okay, so this is 1 minus 3 over 5. That's a 5. Yikes. All divided by 2. Okay, so then we just want to do some, let's zoom in a little bit here. Do some algebra to simplify that. Okay, so then this equals, so let's multiply the 1 by 5 over 5. We'll get a common denominator in here. 5 over 5. So that's going to be 5 over 5 minus 3 over 5, all divided by 2. Okay, now we're kind of out of room here, so let's erase this. So let's remember, sine of alpha over 2 is positive, cosine of alpha over 2 is negative, and tangent of alpha over 2 is negative, so let's remember that and refer to it later. We are out of space though, so we'll just have to get rid of all this. Okay, so anyway, moving on with this. So now this equals 5 over 5 minus 3 over 5 all divided by 2, so that's 5 minus 3 over 5 all divided by 2. So that's going to be 5 minus 3 is 2, so that's 2 over 5 divided by 2. Okay, so 2 over 5 divided by 2, that's the same thing as 2 over 5 times 1/2, all inside the square root still. 2's cancel, so we end up with roots, let's maybe come back up here. So that equals root 1/5, which is the same thing as root 1 over root 5, or 1 over root 5, which is fine with me, but if you have to rationalize the denominator, multiply by root 5 over root 5, and then you end up with root 5 over 5, which I don't believe is more simplified than that, but whatever. Okay, so that's our answer there. If you have to rationalize the denominator, it's root 5 over 5. Okay, so for part A, sine of alpha over 2, that's root 5 over 5. Now for part B, cosine of alpha over 2, remember we got to be careful, cosine of alpha over 2 is negative. We found out earlier we had to erase it to make more space, but it is negative. So cosine of alpha over 2 is plus or minus the square root of 1 plus cosine alpha over 2. Okay, we're going to take the negative square root. Okay. Okay, so zoom back out a little bit. Cosine of alpha over 2 equals negative square roots of 1 plus cosine alpha, all divided by 2. Okay, so it's the same cosine alpha as before, so we already know from earlier that it's 3 over 5. So this equals negative square roots of 1 plus 3 over 5, all divided by 2. Okay, getting kind of messy in there. Okay, so we do have the minus sign on here. So remember, the cosine was negative, or it is negative. Cosine of alpha over 2 is negative, because remember, alpha over 2 is in the second quadrant. So we have 1 plus 3/5, all divided by 2. So minus sign still out there. 1, so if we get a common denominator, multiply that by 5 over 5. So then what we have is 5 over 5 plus 3 over 5, all divided by 2. So then let's come up here, equals negative. So 5 over 5 plus 3 over 5, that's 8 over 5. So we have 8 over 5 and then divided by 2. So 8 over 5 over 2, that's 8 over 5 times 1/2. 8 over 5 times 1/2, all inside the square root still. Okay, so 2 goes in the 8 4 times, so this equals negative, still out there, square root of 4 over 5, which is the same thing as running out of space, so let's erase that. Same thing as negative 2 over root 5, which again would be a totally acceptable answer if you were one of my students, but if you have to rationalize the denominator, let's maybe make that a little easier to read. If you have to rationalize the denominator, that's going to be multiplied by root 5 on the bottom and the top. So that's going to be negative 2 root 5 over 5. Okay? So rationalize the denominator, it's negative 2 over 5 over 5, which I don't believe is more simplified than negative 2 over root 5. But whatever. So negative 2 root 5 over 5 is the answer for part B. Okay. Okay, so kind of a big mess here, but anyway. Part B, cosine of alpha over 2 is negative 2 root 5 over 5. So now part C, tangent of alpha over 2. Now we can go back to our formula sheet and say, okay, I can use one of these three formulas, but let's not do any of that. That's going to be kind of a mess. Let's just use the fact that tangent, let's also erase this here. And let's maybe use a different color. Tangent of alpha over 2 equals sine of alpha over 2 over cosine of alpha over 2. Okay. Sine of alpha over 2 we found out in part A, that's root 5 over 5. And then cosine of alpha over 2 we just found out is negative 2 root 5 over 5. Okay, so let's zoom in on this now. Okay, so now this is going to be root 5 over 5. Okay, so this fraction on top divided by the fraction on bottom, it's going to be the fraction on top multiplied by the reciprocal of the fraction on the bottom. So negative 5 over 2 root 5. Okay, so then root 5 cancel with root 5, 5 cancel with 5, and then what we have left is a negative sign with the 1, it's just a 1 left on top, and then it's going to be negative 1/2. Okay, and that's actually our answer for part C, is just negative 1/2. Okay, so notice this was quite a bit simpler than going through one of these formulas here, right? So if we went through one of these formulas, it would be about as messy as what we did in part A and B. But remember, what's nice about tangent is just sine divided by cosine. So once you know the sine and cosine of alpha over 2, then you can just divide them, and you'll get your answer there. Okay, so that's example 4 with using half-angle formulas. And in this case, we had to resort to reference triangles. So, and here's the answers again. Root 5 over 5, negative 2 over 5 over 5, and negative 1/2.